Hello everyone, my name is Yash Patil and I am second year engineering student pursuing my MBA Tech from NMIMS University. Today I will be explaining a topic from design and analysis of algorithm which is optimal merging problem. This topic is very important because it helps us to understand how to combine data efficiently while reducing cost. Let us understand real life context of this problem where we use this problem in real life. This concept is used in many areas like databases system, where large sorted data is merged, file compression, where data is combined efficiently, and external sorting, where files from storage are merged. So this problem is just not theoretical, it is used in real life, real systems. Now, let us look at the main challenge. The question is, how can we minimize the total cost when merging multiple files? Here, cost means the efforts required to merge the files. And one very important thing is the order in which we merge files affects the total cost. So choosing the correct order is very important. Now let us see one example where we will merge the given files in wrong order. Suppose we have three files. Suppose we have three files given size of 10 MB, 20 MB, and 30 MB, 10 MB, 20 MB, and 30 MB. If we merge, if we merge larger files first, like 20 and 30, 20 and 30, the cost becomes 50. Then we merge 50 with remaining 10. First we take 20, then 30. We add the larger files first, 20 and 30. Then we merge that total we get 50. Then we merge that 50 with remaining 10. We get 60. 50 plus 10, 60. So the cost becomes 60. And then total cost we get is 50 plus 60 is 110. This is a high cost which is not efficient. So this example is of wrong order. Now let us see the same example where we will merge the file in correct order. Let us take again same example. Here we have given the files of size 10 MB, 20 MB, and 30 MB. First we merge the smallest files like first we merge first we merge the smallest files like 10 and 20. 10 plus 20. We get total cost is equal to 30. Then we will merge 30 plus 30. The first 30 is of 10 plus 20, which we have merged 30, and we will add remaining 30 MB file in that 30. So total cost we will get is 60. So, no, sorry, the cost we will get is 60, and we will get total cost by adding 60 and 30 is equal to 90. 60 plus 30 is equal to 90. The cost is lower than the previous one, so this proves that the merging smaller files first gives us better results. Now, let us understand the strategy used in solving this problem. Solving this problem, we use greedy approach. The rule is very simple. Always merge two smallest files. Now, let us understand why this works. When we merge smaller files first, their cost is added fewer times. But if we merge larger files early, their cost get added again and again. This increases the total cost. So merging smaller files helps us to get reducing the overall cost. Now let us understand the greedy choice property. This means that at every step, choosing the best option, which is the smallest file, will lead to the best final result. So local based choice gives us global based result, global based solution. Also, larger files are merged later. This ensures that their cost does not get repeated many times, but this is the main reason why this approach is efficient. So till now, we have understood what the problem is, where it is used in real life, why merging order matters. We have taken the example. First, we have merged the file in wrong order, where the total cost we get is much bigger than the cost we get by merging the file in correct order. So till now, we have understood that what the problem is, where it is used in real life, why merging order matters, as we have seen in above examples, where we merge the files in wrong order The total cost we get is much higher than the files we have merged in correct order, than the total cost we have get when we merge the files in correct order, and how the greedy strategy works. Now, with this understanding, we are ready to move to the next part. My teammate Siraj will explain the algorithm and the working in detail. Thank you.
Hi guys, I'm Chirag and I'm a second year MBTech student at NMIMS Shirpur, and I'll take you further to the problem question on optical merge sequence. Now to solve optical merge sequence you have to remember two steps. That is, add two shortest element from the list and update the list in ascending order. Now here with the problem we are given with 7 files that are already in sorted and in ascending order. Now, going with the first step, we have to add two shortest elements from the list. Now, these two elements are 10 and 20. Adding them would be 30. Now, your new list is 25, 30, 30, 35, 40, and 45. Now, adding the two shortest elements from the list would be 30 and 25. That is 55. Now, your new list is 30, 35, 40, 45, and 55. Now adding two shortest elements from the list is 65. Now again your two shortest element from the list is 40 and 45. Adding them would be 85. Now your new list is 55, 65 and 85. Now two shortest elements from the list is 55 and 65. Adding them would be 120. Now you are remaining with two least elements, that is 120 and 85. Adding them would be 205. Now to calculate the total minimum costs, you have to add all these entities given in the circle. Now adding them you will get 560. Now this 560 is your final answer to the problem, and this is your total minimum cost. Now jumping ahead to the next problem, we have 10 elements given in the problem. Apply the total merge pattern technique to determine the minimum total cost of merging 10 files whose record length are this. Now for the sake of time I have already sorted this element. Now uh, going with the first step, uh, we have to add two shortest elements from the list, that are 5 and 3. Adding them would be 8. Now going with the second step, we have to update the list. Now updating your two shortest elements from the list would be at 8 and 11. Adding them would be 19. Now moving ahead, your two shortest elements from the list is 19 and 12. Adding them would be 31. Now your two shortest elements from the list is 31 and 28. Adding them would be 59. Now your two shortest elements from the list is 32 and 35. Adding them would be 67. Now again you have to update the list. Now your new list is your 53, 59, 67, 84 and 91. Now adding two shortest elements from the list is 53 and 59. Adding them would be 112. Now your two shortest elements from the list is 67 and 84. Adding them would be 151. Now your two shortest elements from the list is 91 and 112. Adding them would be 203. Now your two least elements is 151 and 203, and adding them would be 354. Now you're exhaust with the list, and here are the values we are getting. Now to calculate the total minimum cost, as I've told you earlier, we have to add all these entities in the circle. Adding them you will get to 1004. This is your answer to the problem, and this is your total minimum cost. Now jumping ahead to the data structure used here. We have used minimum heap and or we say priority queue here. Faster retrieval of smallest elements, that is order of 1. Efficient insertion of merge results, order of log n, and automatic reordering after each operation is the some operation by minimum heap or priority queue. Now moving ahead, algorithm for optical merge pattern. Now with the algorithm we'll see and we'll calculate time complexity for the optical merge problem. Now for the step 1, uh, take input as a list of sizes. Now here with the problem, here with this step, we'll get order of and time complexity. Now going to say step 2, insert all the file sizes into a minimum web or priority queue. From here we'll get order of log n. Uh, Now going to the third step, initialize total cost is equal to 0. This is okay. Now moving to fourth step, remove two smallest files from the heap A and B. From here you will get order of log n. Now moving ahead to the step 5, compute cost is equal to A plus B and add cost to total cost. Now from both these you will get order of 1. Moving to step 7, you we have insert merge file A plus B in back into heap. Now from 7th step we'll get time complexity as order of log n. Now step 8, repeat step 4 to 7 until only one file remains and return total cost. Now adding up all this will get order of n log n. So yes, order of n log n is your total time complexity for optical merge pattern. So moving ahead, I have also mentioned code in C++ for optical merge pattern. You can go through this code. Moving ahead, as I've told you earlier, time complexity in applications. Time complexity for optical merge problem we have calculated as order of n log n, and space complexity we have calculated as uh, order of n. Now here are some practical applications that has been already been taught by Yash. Uh, these are file compression, data merging, and external sorting. Now at last we have some key takeaways, that is we saw how greedy strategy works and efficient implementation and real world relevance. So this was all about optical merge problem. So thank you.